Welcome, Algebra 2B, and this is another lesson on radical equations. Today, specifically, how do you solve a radical equation? A few key things. First step, always isolate the radical to one side of the equation if you need to. Then you're going to raise it to the identical power in order to cancel out the power. Then you're going to solve the polynomial equation. And the last check is to look for extraneous or solutions that will actually not work solutions. So let's look at examples and basically go through a lot of these types of problems. So for our first example here, we are trying to solve the square root of x plus 6 is equal to 3. The first step, so isolate the radical. That is already done. It's all by itself. Okay, so the next step is to square. This is a square root. We're going to square each side. Okay, square the left, square the right. What that does is essentially just leaves us with x plus 6 is equal to 9. Okay, so x plus 6 is equal to 9, 3 squared. Then you just subtract the 6, so you're at this step, and then you can subtract the 6, bada bing, and 3 is equal to x. Easy peasy stuff. Now, again, the last step, number 4. Okay, step 4, so is to check for extraneous. You do that by just substituting back into the original equation 3, and for x plus 6, we see if that's equal to 3, and we have a square root of 9 is equal to 3. Hey, that checks out, so that is a real solution. All right, for example number 2 here. First step, again, identify or get the square root by itself. That's already taken care of. Then we can raise each to the third power, so 3 to the third. 3 to the third is 27. What's inside comes on out. 2x plus 7 is equal to 27. From here, we'll solve, so subtract 7. 20 equals 2x, divided by 2. X equals 10. Okay, that's what we think it is. We're not sure yet. Okay, so we will substitute it on in. The cubic root of 2 times 10 plus 7 is the cubic root of 27 cubed. Is that equal to 3? Yes, it is. So it does work out. Okay, so always check for extraneous solutions. More so when you'll have examples that don't work out, but we'll still check. We'll get into those in a little bit. So for example 3 here. First idea, isolate the radical. So this is what we want by itself, which means we need to subtract a 1. All right, that gives us negative 2 is equal to the cubic root of x minus 5. Then we'll raise each to the third power. Negative 2 to the third is negative 8. You have x minus 5. We'll add 5 over. Add 5 over. X is equal to negative 3. Before I box it off, it'll be a good idea to check. So let's check and see that that works out. We have the cubic root of negative 3 minus 5, and then we're going to subtract or add 1 and see if that's equal to negative 1. Okay, so the cubic root of negative 8 plus 1, the cubic root of negative 8 is negative 2 plus 1. Is that equal to negative 1? Indeed, it is. Okay, so this solution does work out. All right. How about you give this one a shot? All right, think about what you might need to do first, so you can pause it here and come back to it. I will, of course, go on through. First step is to get this radical by itself. You'll divide each side by 2 first. That gives you 2. Cubic root x minus 3. This point you can cube each side. 2 to the third is 8 is equal to simply x minus 3. Add the 3 over. 11 is equal to x. We're not sure about it yet, so we won't box it off. So first we'll check to see if it works. 2 times the cubic root of 11 minus 3 equals 4. Cubic root of 8 equals 4. So we have 2 times 2 essentially. Does that equal 4? Yes, it does. So this one does work out. All right, if you got that, awesome stuff. More examples. Today's all about examples. So you might see it look a little differently here. Okay. The way you want to do this one is actually we're going to raise it to the reciprocal power. All right. We're going to raise it instead to the 3 halves. All right. If you were to think of this as really it is the cubic root of 3x plus 4 squared, raising it to the 3 halves would also take care of it. So we'll raise each side to the 3 halves. That's just the reciprocal of the fraction. That's going to leave us with just 3x plus 4. If you type into your calculator 16 to the 3 halves, you get 64. From there, subtract 4. 60 is equal to 3x. Divide by 3. X is equal to 20. Again, gotta double check. Always gotta double check here. So we'll substitute that into the original equation. 3 times 20 plus 4, all raised to the 2/3. We're checking to see if that does equal 16. 64 to the 2/3 is equal to 16. That is a 2/3, I'm sorry. And if you type that in, essentially we do get that to work out. 16 equals 16. It checks out. You can box it off and put a nice smiley face next to it. So it does work. Okay. Similar with this one, only first we want to isolate the radical. This is example 6. So we'll add 1, gives you 8 is equal to x plus 2 to the 3/4. If you're telling yourself, well, that means I need to raise to the 4/3, you are absolutely correct. That gives you x plus 2 is equal to 8 to the 4/3, turns out to be 16. Subtract 2. 14 is equal to x. Hey, there, that's all you need. But let's check. Okay, so again, check it on out. Our original equation is 14 plus 2 to the 3/4, and then don't forget the minus 1 is equal to 7. This is 16 to the 3/4 minus 1, which is 8 minus 1, which means 7 is equal to 7. And we are happy to go from there. Alrighty. 2 more examples. Okay. So go ahead, feel free, try these ones out maybe, okay? Try them out, and then, so pause here, and then come back to see what you get, all right? For me though, we're just going to go right on in. Need to isolate the x to the 2/5. We'll multiply each side by negative 3 halves. That'll make it nicer for us. 6 times negative 3 halves is 9. Is equal to x to the 2/5. Take each to the 5 halves power. We have x is equal to 243. Let's check it out. 2/3 times 243 to the 2/5. See if that's equal to negative 6. Long story short, if you were to do that, you do get them to be the same. So it does work out, and we're happy. Okay. Last one here, add 21, negative 53 plus 21 is negative 32, is equal to negative 2x to the 4/3, divide by negative 2, we get positive 16, equal to x to the 4/3. Raise each to the 3/4 power, and we have x is equal to 8. Always a good idea to check. So negative 2 times the quantity 8 to the 4/3 minus 21 is equal to negative 53, and it does check out. Okay. So solving, these are pretty simple actually compared to some of the other things I like to think. So good luck, try some out for your homework.